Today we're talking about roots and some of the properties that roots have. If you notice here, if you have an nth root, so that means any number, and inside you have a times b, or really any number times any number, you could split those up into two different roots. You can always go backwards too. If you have two roots being multiplied, you can put them both under the same root. Okay? Dividing, we've talked about this before, when you have the root of a fraction, you can end up putting the root over a root. But one thing to remember is that you shouldn't have a root in the denominator. Okay? So, a lot of this should be pretty easy, kind of like last set of notes. But so for 625, we're going to break it down. How many do I need for a group? Four. Okay, so 625 is 25 times 25. And then 25 is 5 and 5. And this one's 5 and 5. So I have one group of 5s. There are multiple ways of doing this. This x to the 8th power, we could write out 8 x's if we wanted to. But we know that how many do we need for a group?
4.
So what I normally will do is write like x to the 4th and circle it because I know that makes 4 x's. And then I'd have another x to the 4th. That would make a group. And that made 8, right? Do I have any left over there? No. And then I have y to the 4th that I'm going to write. And then z to the 12th is going to end up being z to the 4th, z to the 4th, and z to the 4th, because that makes 12, right? And there is nothing left over. So what will my answer for this one end up becoming?
5x.
Wait, how many groups of x's do I have? 2. So that's going to be x to the, no, second. Just like this group of 5s, this is really 5 to the 4th power, right? Do you guys agree? Which just becomes a 5 when we bring it out. Each group just becomes 1. Okay? So since I have 2 groups, that's just going to be x squared, because this becomes an x and this becomes an x. This will just be y, and then it'll be z to the 3rd, because there are 3 groups, and that's my answer. Okay? All right. Example 2. Yes?
Can you only break it into powers of 4?
Yes. So, like, let's say if this was like z to the 10th, okay? I would have gone z to the 4th, z to the 4th, and then I'd have z to the 2nd left over, which would not make a group, and it'd have to stay inside the root. So, in order to pull something out, there has to be 4, and it just happened that there were groups of 4 for all of our variables and our numbers. So there wasn't anything left over. But if there isn't 4 of something, then you would leave it in your root. Okay? So if we look at, let's look at example 2 right now. So 27 breaks down to what?
3.
Good. And then 9 breaks down to? And how many do I need for a group this time? 3. Isaiah, are you doing this with us? Okay, 8 to the 2nd. Is there enough to pull out a group? No. So that's the one where I usually will like box it to remind me, oh, that needs to stay inside. B to the 7th. How would I break that one down? No, I'm going to have B to the 3rd. And then another B to the 3rd. And then how many are left over? 1. So I'm going to write B and box that one because I know it's going to stay inside. Okay, so then with the C's, what am I going to write? C to the 3rd, and then how many do I have left over? A C. Okay, so that one circles, and then this one is boxed and left inside. So you have to pay attention to what your root says to make sure that you have the right amount. Okay, so when I write this answer, what is going to be written on the outside of the root?
3b squared c.
Very good. 3b squared c. Because we have one group of 3s, I have 2 groups of b's, and 1 group of c's. Okay, then we write our root. One thing to be very careful of is that you write the correct number here. So make sure you still have your cubed root. And then left over inside, look for everything that's boxed. So I have an a squared, b, and c. And that's what's left over. This is my answer. Do you have questions on that? Okay, so on example 3, how many do I need for a group here?
4.
So if we break 27 down, we've kind of done this a lot already. 27 breaks down to what? And then it becomes, so this is really 3 times 3 times 3. Do you guys agree that that's what the denominator is right now? But I need how many in order to make it a group?
4.
I need 4. So what am I going to do? Because we can't have that root in the denominator, right?
Bring
And
it up.
so what do we do in our last unit in order to get rid of that root in the denominator?
Multiply it.
Multiply it by,
Conjugate.
you just need one more 3, right? So that means I'm going to multiply the top and the bottom by just one more 3. If I needed 2 more 3s, then I would multiply by 2 more 3s. Okay, in this case, I just need one more 3 in order to make a group of 4. Okay, so this makes our group of 4 3s. So my denominator is going to be what?
15.
No. My denominator is just 3. And on the top, I have 15, and it's the 4th root of 3. Don't forget that that's a 4th root.
So you can divide by 3.
So now we can reduce, and 15 and 3 reduce to what? 5. So we end up with 5 and the 4th root of 3 as our answer. So just remember that you can only reduce numbers that are both on the outsides of roots, or you can reduce numbers that are both on the insides. Okay? Okay, so example 4 here, I would probably go ahead and rewrite this as, yeah, exactly, 2 roots. The 5th root of 3 divided by the 5th root of 4. Now, can 4 break down? What does it break down to? Good. So again, I still have the 5th root of 3 over, and this is the 5th root of 2 times 2. But I can't have that root in the denominator, so how many more 2's will I need? I need 3 more. So that means we're going to multiply by the 5th root of 2 times 2 times 2 to both the top and the bottom. Okay, so that made my 5 2's that I needed to make a group. So my denominator is what? 2. And on top, between the 3 and the 2's, is there any groups that I can pull out on the top? No. So we're just going to end up multiplying everything together, right? Because you need 5 of something in order to pull it out, right? And I do not have 5 3's and I do not have 5 2's. So we multiply all that together, and I know that 2 times 2 times 2 is 8, and then 8 times 3 is... So that means I have the 5th root of 24. And that's your answer because there's nothing in front to reduce with the 2. Questions? Okay, example 5. Do you think you guys could try this one on your own? Good, I think you can. I'll give you a minute. Not too bad. Once you think you have your answer, raise your hand, I'll come around, or you can write it on your whiteboards. This is right. Good. Don't forget that this looks like it's a 4. Make sure you put the 4 like inside there. Yeah, and that 4 should be
not that one.
Okay, you should have ended up getting the 4th root of 2. Okay, so what does the 4th root of 8 break down to? Shh. 2 times 2 times 2. And then I still have a 2 on the top. And how many do I need to make a fourth root here to get rid of my, how many more 2's do I need? Sorry. 1. So I'm multiplying by the fourth root of 2. Please notice where I'm writing my 4. Do not put the 4 in front of the root because that will look like it's a regular number. So that 4, whatever number, should be like inside that little root part. So now I have a group of 2's. So my denominator is 2. And then on top, I still have 2 in the fourth root of 2. Can anything reduce there?
Yeah.
Yes, these 2's that are both out in front. So those reduce or cancel out, and we end up with the fourth root of 2 as our answer. Any questions? All right, example 6. What do I do with this? What do I do with this? Put this over a 1, and then we have to get rid of this negative exponent, which comes to the bottom. So I have 3 over, and instead of writing x to the 1/2, we could write that as what? The square root of x. Do I need to put this 2 here? No, but if you want to, you can. Okay, can I have a root x in the bottom? And how many more x's will I need? Just 1, because this we only need 2 for a group. So when you bring this to the bottom, this is x to the 1/2 power. Remember that the 1 part is your power or exponent, and the bottom part is your root. And so this ends up becoming, this 2 right here, it goes right here, but we don't normally write it. And then this 1 right here goes right there, and you don't normally write it. So we need 2 for a group, and now I have 2 here in the denominator. So my denominator is x, and then my numerator is just 3 root x. And can I reduce anything? No, that's my answer. Okay. Oops. Is it okay to have a negative number?
Yes.
Yes, it's just not okay to have a negative exponent. So I'm going to rewrite this. We have the cubed root of 2 on top. On the bottom, I have negative 3, and I have the cubed root of, and 9 breaks down to what? 3 and 3. Okay, so how many more 3's do I need? 1. So I multiply by the cubed root of 3 to both the top and the bottom. We have a group of 3's.
Do you have, on the top one, you have 3 square root of cube root of 6?
Yes. So on the top, we would multiply those together, and you'd have the cubed root of 6. And the denominator, here's a group of 3's. There's already a negative 3 outside, so what happens? You multiply them. You're taking this right here, negative 3, and you're multiplying it by your group right here, which is 3. And negative 3 times 3 makes a negative 9. And can anything reduce there?
Yes. Oh,
No, because we can't reduce inside the root and not inside the root, right? Okay.
Looks like it's gonna rain.
Okay.
Well, it's not.
All right. Moving on. Oh. No, you can. You just can't have a negative exponent. Negatives are okay. Negative exponents are not.
I have my umbrella.
You just can't have a root. You can have a fraction. Okay, example 8. Shh. Okay, what is my issue on example 8?
Maybe the negative exponent inside the square root is your issue?
It is. So we are going to bring that to the
Tom!
bottom.
Oh, yeah.
So we're going to have the fourth root of x cubed still on top because that part was okay. And then we're going to have the fourth root of y to the fourth in the denominator to get rid of that negative 4 exponent. Notice that if this is under a root here, you need to keep it under a root when you take it to the denominator.
See that now.
How many do you need for a group on this?
4.
How many do I have? 4. So I have one group, right?
Yeah.
So when that comes out, what does it become? Y. And then can I take any x's out? No. So we just have the fourth root of x cubed on the top. And nothing simplifies, that's your answer.